Hybrid Cloud Show, Episode 19. I'm Aaron.
I'm Gary.
I'm Sean.
And I'm Shane.
Welcome to the show about public cloud, private cloud, and everything in between. Our views here are ours and not those of our employers. Well, we're nearing the end of the year, and so I've got a question for you where we can all look back on our lives in public cloud and try and decide what's the most significant advance that we've seen.
Obviously, Aaron, the answer is Gen AI. That's what all the cloud providers are talking about, right?
Good God. Not here. I'm going to go back. I think that the biggest advancement for not just public cloud, but also private cloud and hybrid cloud has been the new technologies that have come out for networking. I'm thinking things like Tailscale, Nebula, those kind of mesh networks, and especially how they allow you to integrate your actual services as basically just host names on top of this mesh networks that you create has been transformative. And it's opened up a whole entire industry.
Yeah, it's a good point. I hadn't thought of that, but that's a good suggestion.
So I agree. They're a pretty cool piece of technology, but I'm not seeing widespread adoption of them in cloud, in large enterprises. But there probably is a place. So have you got some use cases in mind that you think they're really good for?
Yeah. When you're in a public cloud, it's a little different because you already have technologies like transit gateways and internet gateways to help you kind of get that traffic into wherever you're at. But if you're trying to go from east to west Kubernetes or trying to go multi-cloud or even a hybrid cloud, right? How do you connect those together? And yes, there are still you can still use a transit gateway to do into your on-prem. You can still kind of do that if you want to achieve a hybrid cloud on one, but that's just between two clouds. It's very hard to scale that out between all the different cloud providers. And so you don't have to think about any of that stuff if you use one of these tools like Nebula or Tailscale, because then they all just appear on a flat network, no matter where they're at, that are easily addressable by the same, host name you'd expect, no matter if that's on your private cloud, public cloud, multi-cloud, or wherever it's at. And like I said, east to west traffic is where I've mainly used them between two different Kubernetes clusters to be able to easily do that without having to route out through the internet and try to hit a WAF and then come on in or something like that.
Yeah, I've seen people using it just for the consistency as well. So if they're not that familiar with the particulars of a public cloud and how you should do things native to that cloud, I've seen them using things like Tailscale, Headscale, Nebula, those sorts of technologies so that they can take a consistent approach, whether they're talking about using that in a private cloud environment or whichever cloud they're landing that workload on.
I've also seen in smaller scale implementations, people using them to do things like run that inside a container with a reverse proxy so that you can just address a service directly from your tailnet or whatever it might be. So you run, say, an Nginx reverse proxy container with a Tailscale user session in it, and then that enables you to basically get to whatever's running in a container that's sitting in the same network. So there's some cool stuff you can do there as well. So you're not exposing those things to the public internet or even actually exposing them outside of your cluster.
Exactly.
So I guess the real question there becomes, what is the value of running something like Tailscale across clouds rather than just using some kind of VPN between on-prem and Azure or AWS and Azure? I know you mentioned having one big flat network. Some might say that's a disadvantage because then you've got to manage all of those security groups and things inside your mesh network provider rather than using the tooling that the cloud provider gives you. There's a bunch of unknowns there, or I guess it's adding another layer of complexity to what otherwise would be a somewhat simple problem to solve.
Simple to you, Gary. You're a very smart individual. You have a lot of experience, and like Aaron said, there are some people out there that don't and kind of just want that consistency, a single place to go and view their stuff, a single network to go and see their stuff. And yeah, you can split up your mesh networks into multiple pieces, right? Not so that everything is all on one and everyone can see everything, right? But you are correct. It is additional overhead. The question is that additional overhead worth it to your group, or do you have experts that do know how to do this natively? It's all about trade-offs, I guess.
Well, much like everything. If you want to go and spend the time learning Tailscale or Nebula over going and learning the native VPC constructs of your chosen cloud provider, then yeah, sure. And I can see how it would be valuable in something like a platform engineering space to just say to developers, hey, you get your sidecar container with Tailscale and Nginx in, and that's how you get in from your workstation, or that's how you get in from the dev cluster that's in Azure to something that's maybe sitting in AWS.
I think when I heard the question, Aaron, I kind of went a little more like fundamental in terms of concepts. And I think one of the big things that's come from cloud is serverless technology. And it's needed a concept like public cloud to produce something like this. So I'm pitching for that.
What's so good about serverless? I know that some problems can be solved by like just scaling pods, but why serverless versus scaling up what you already have?
Well, you'd have to provision what you already have ahead of time. With serverless, I'm not dealing with any resources until there's a need for them. On top of that, like you're abstracting away the infrastructure. I'm thinking about this from a platform engineering perspective, I guess, but you're abstracting away the whole infrastructure layer. Engineers are writing code and shipping it to a serverless blob, and that's it. They're done. Huge demands in compute are needed. Great. It'll spin up. I don't need to think about any of this at all. It's solved. So for me, that's really powerful. Again, you need that serverless shaped hole to fit it in. So if you've got event-driven workloads or something with workloads that need to scale down and scale up quite quickly, it solves that. It doesn't solve every problem, but it solves a good amount of problems to be, I think, really, really helpful.
I had a really novel serverless use case recently, which I would have traditionally thought of as something that I would just do in a VM, which was using it to execute FFmpeg on really large files that were stored in S3. So the way that this particular person was saying to me that they did this was they had some really large pieces of archive footage sitting in object storage, and they wanted to pull these out of object storage and transcode them to a format that a user had chosen. Now, to me, I would have probably run that traditionally on something like a Kubernetes cluster and spun up a bunch of pods, done the FFmpeg transcode because I knew it was going to take longer than the 15-minute timeout for Lambda, and then put it up to another S3 bucket somewhere and had the user pull it down and then expire the link after half an hour or whatever. But what they were saying is that they would manage to basically parallel transcode different blocks of these large files so that they could finish the transcoding way more quickly. And they just spun up 100 lambdas, transcoded 2-minute chunks of the file, and then put them together at the end, which was a way less intensive process, and then put that in an S3 bucket and had the user pull that down. So you talk about filling a serverless shaped hole, or you have a problem that fits a serverless shaped hole. But actually, I think that it can have way wider of a set of use cases than just something event driven.
Was that designed that way because of the 15-minute timeout, or was that something they wanted to do anyway?
It was both. So they wanted to very quickly transcode the file. They realized that they would need some really, really big compute instances in order to transcode that file in a time that was meaningful for a user, because obviously they were sitting there watching a progress bar go across the screen while their file was being pulled, transcoded to the format they needed, and ready for download. And what they realized was that, yes, they needed it to execute in less than 15 minutes to run in their function app, but that actually they could use that to their advantage by massively parallelizing that workload. So yes, it was a problem, but actually it meant that there was a better user experience as a result of being able to do that massively parallel instant scaling that serverless gave them.
That's interesting to me because Amazon Prime Video wrote a blog post a couple years ago about how they did the exact opposite and how they had a service architecture for transcoding their media and they switched to dedicated EC2 instances.
I suppose it depends on scale, right? Because Amazon Prime Video, I've got to imagine, are transcoding thousands of video streams, if not millions of video streams at once all the time. Whereas this was very specifically, I would like to request this thing from this archive in 480p.
That's a good point.
Whereas if you're Amazon Prime, it probably makes a lot more sense to have those big instances ready to roll and do the thing because you know that work's going to come. So for this guy I was speaking to, actually their use case was more spiky than that. So they might have a user come in twice a week and say, I want this footage from the archive. That's not something that they could readily predict.
That does seem to fit a serverless shaped hole.
It's super scalable, essentially. And it's interesting that your friend was willing to add complexity to leverage that hyperscalability. Whereas I guess an Amazon Prime might have fairly predictable transcoding needs and can dedicate specific resources to it.
Yeah, they made that trade-off, right, of complexity and cost. Because yes, they probably could have spun up a massive NVIDIA Tegra worker node or something in their Kubernetes cluster, but that's hugely costly rather than just running a bunch of Lambdas in parallel for 15 minutes at a time.
I'd also kind of argue that serverless has had a positive environmental impact. I feel like personally, I've had a lot of servers running and doing absolutely nothing for very long periods of time. So the idea that the compute is on demand and not just sitting there waiting for the opportunity to run something, and you over provision just in case. I think it may have had a positive environmental impact. I have no numbers to back that up, but it feels good sometimes.
It's the sort of logical conclusion, well, even further if you go to the functions and things, but it's that logical conclusion of stripping away all of the layers that you don't want to be managing underneath the very small thing that you want to be thinking about.
Yeah. And again, for the platform engineer and me, abstracting away all the problems to something that's just solving precisely what the customer needs is a win for me.
So for me, I'm going to go even more meta than Shane, because I don't think it's a specific cloud technology that has changed the way that people work over the last 10 years or whatever of public cloud being widely adopted. I think it's some of the architecture patterns that have come about as a result of public cloud. So I'm thinking about things like microservices, for example, that people maybe did on-prem, but didn't do particularly well. Those things were tightly coupled. I'm thinking about things like event-driven architectures that we've talked about before. Thinking about things like message queuing. I'm thinking about things like even domain-driven design and all of these principles that just didn't exist 10, 15 years ago that we now just work to every day. And I think it's pretty safe to assume that if you're building something now, you're building small, loosely coupled services that do one thing and do it well, and then integrate nicely with each other and are built so that if one part fails, messages can queue up somewhere and be consumed by something else when it comes back. And just workflows that really fit nicely together and are way more resistant to failure than a large monolith, or if I can't call API number 2, then API number 1 breaks. There's stuff like that that just didn't really exist.
Yeah, I think this speaks to technology as a whole sort of maturing. I think there historically has been a world where the business kind of figured a way to align itself with how IT and tech worked. Whereas, and in particular when you say domain-driven design, Gary, it's now we've gotten to a point where technology is abstracted enough where we can take the tech and have it fit the business.
Yeah, we're solving business problems with technology now rather than just building applications to enable some kind of process or something.
I think we've talked about it before. I'm sure we've talked about it before on some of the other shows. These things often were possible. It's just that the nature of the way that the clouds have evolved and the way they make these things available to people fits some of these new paradigms a lot easier than was possible before.
Yeah, and we've learned to make them resilient, right? So I worked somewhere 7 or 8 years ago where we did have this concept of small, we called them web services, but effectively they were microservices, right? That if you wanted data about a specific product, you would call the product web service and you would get that data returned to you. But no one thought about what if product web service doesn't respond in a timely manner, or what if it goes away? Now we're actually thinking about those things, and it's making our systems way more resilient than they would have been 10 years ago. And I think we have learned as technologists to assume that things aren't reliable rather than assume that they will respond in the way that we want. And that's got to have improved the user experience overall of the applications that we're building.
Yeah, things have gone from you should probably know what you're running to I'm going to blow this kettle away on a regular basis, and that requires you to know what you're running.
That's a great feeling. I love that feeling. Just doesn't work for whatever reason, blow it away, redo, I'm back.
And I feel dirty now if I have an Ubuntu server sitting around that's not running the latest interim release. Because why haven't I rebuilt this in the last 6 months? What am I doing? It just feels filthy. I don't know why. Think of all the logs and stuff that are on that box that you probably should have shipped off somewhere or deleted.
Yeah, I don't miss the days of like, oh no, there's too much traffic hitting our Apache server. Let's tweak some config variables on the one server we've got to try keep it going for another couple of weeks.
Or why does the web config on this server differ from the other one in its pair? And why does that one fall over at 3 a.m. and the other one doesn't? And what particular setting is it that someone's gone in and tweaked? Yeah, no, I'm glad those days are gone.
Piggybacking off of that, all of the cloud tools that we now use, like Terraform and Ansible and Puppet and Chef, to manage these things at scale so we can do cattle instead of pets, have been transformative. And I don't know anybody in the industry that hasn't at least had some experience with them.
It was my second choice for innovation. It was infrastructure as code. The idea of like codifying infrastructure when I started was impossible. And you can spin out stupid amounts of compute with the wrong sort of for loop or whatever is very powerful and very cool.
Very painful for your credit card.
Yeah.
Yeah, infrastructure as code was up there for me. But in the end, what I decided was to again go back a step, a bit like Gary, and say, I think it's amazing how these things have turned into platforms. So how these clouds have gone from the conceptualization that they were like a server you could run in your own data center by the hour, and very much built these whole ecosystems and platforms and control planes and ways of interacting with them that have built up marketplaces and all the rest of it. To the degree that now I think when you look at some of the smaller cloud providers that we've talked about before, we often come back and say, oh, well, they come with these downsides because they don't have the same ecosystems around them. So I think that whole ecosystem, platform, marketplace play that's grown up around something that could have been a relatively transactional, I need a bit of server resource, it's got its pros and cons, but I think it's been transformative for the industry.
Well, at least 50% of us now get paid to abstract away some of that complexity that those platforms bring.
Yes, sir.
Mm-hmm.
But on a more serious note, I do agree with you, Aaron. I think the ability to have my Linux VM connect to a database and for me to be able to define as code what the permissions that server has over that database are and not have to do things like have a password to connect to my Postgres database because I just say, if it's a server and it's tagged with this thing, it can connect to you. That's truly transformative compared to what I would be doing if I were building that myself on a couple of VMs. Because then I'd have to worry about secrets rotation and storage and all of this other stuff that when you have this cohesive platform almost goes away. I mean, obviously we all know it doesn't go away, right? But the kind of stuff that I guess Amazon would call undifferentiated heavy lifting that everyone can and should and needs to do isn't my problem anymore. And that someone else is doing it in what I hope is the right way is just amazing. It's stuff that you shouldn't have to think about.
Yeah, and some of those pieces around fitting business processes into the way the cloud works have been very clever business plays. So the fact that you can have an IAM role or whatever that is just about managing other IAM roles, and the way that you can, differentiate your costs out into particular cost centers, and the way that you can do all of your budgeting and all those kinds of things that are really important to businesses are a very clever way of making it harder to use the other providers or to let's turn that around and be positive. It gives a nice, useful business benefit to using a particular cloud provider.
Well, you mentioned cost there, and I think that's a really important thing that the cloud gives you some transparency over that perhaps running this stuff on your own tin didn't, or certainly in a different way. So you can almost use cloud spend as a pseudo proxy for devices shipped if you were doing some kind of IoT workload, right? And you can kind of see, yeah, okay, we were shipping a bunch of devices and now we've gotten to the point where we have enough compute and there's enough overhead there that as we're shipping the next 1,000 devices, our costs are staying flat. And being able to see trends like that, you just wouldn't have seen if you'd gone to Dell or HPE and had to put a bunch of servers in a data center. It wouldn't scale that way, and you would just have to hope that you'd provisioned enough resource to support the next 1,000 devices. And you would never really be able to tell if you'd over-provisioned yourself massively to begin with, if your resource usage on your server was scaling linearly or not linearly with the growth of your clients. There's a whole bunch of cool stuff like that that you can just do now. And it comes for free out of the box with every major cloud provider that I think is really cool.
And think about the businesses that can now start because that exists versus I can't make this massive upfront investment and this complete bet, assuming a certain level of demand. So yeah, even for that, like it's had a huge impact.
What do you mean I can't just go and lease a bunch of stuff and then default on it, Shane? It sounds perfectly normal business practice.
Honest businesses, Gary.
Well, we better wrap this up. Before we do, thanks to our existing PayPal supporters and patrons. If you'd like to join those people, you can at hybridcloudshow.com/support, where for various amounts on Patreon, you can get an ad-free feed of either just this show or all the Late Night Linux family shows. And sometimes you receive episodes early. If you'd like to send us any questions or any feedback, please do at show@hybridcloudshow.com. We'll be back in 2 weeks. Until then, I've been Aaron.
I've been Gary.
I've been Sean.
And I've been Shane.
See you later.